We will also publish a blog post later today, which will link to a service that we are going to announce later today. So stay tuned about this. Also, let me close the window. Yeah, don't want you to have annoying sounds coming from here. And okay. Okay, it's 8:03. Can still wait for a couple more minutes. I believe. Okay, I'm also recording this call, and yeah. Okay. So I think we can start without further ado. My name is Daniel Kornev. I am a Chief Product Officer at DeepPavlov. And today is a big pleasure for me to talk to you about the way how we build knowledge graph-infused multi-skill AI assistants and how you can do the same using our DeepPavlov Dream platform. This talk would not be possible without help from our team who is working on DeepPavlov Dream platform, but also with folks who work on the knowledge graph infused components, and specifically Dmitry Evseev and Maxim Telemanchuk, who helped me also to show you a pretty cool demo later today. So let's get started. So in the last few years, our organization had a fantastic opportunity to participate in one of the biggest conversational AI challenges, which is called Amazon Alexa Prize Social Bot Grand Challenge 3 and 4. And the goal is to build a social bot that can engage in fun and high quality conversation covering different societal topics for 20 minutes and get an average rating of at least 4 out of 5. And also there are lots of differences between the social bots that were built by teams from the top universities across the world. There's a commonality. Teams use some combination of scenario-driven approach with neural generation, and many of them rely on knowledge graphs, and this over a different way. However, the more we use neural generation, the less we can control the quality of the conversation. And given that users accept, a sequential and engaging conversation, scenario-driven approach is a sort of a priority for us. Now, there are lots of differences between different social bots that were built in the last 4 competitions. But it's very clear that the most popular approach is combination of neural approach and symbolic approaches. Teams build up their chatbots by combining the power of the finite state machine frameworks with the machine learning and deep learning NLP models to maintain a healthy balance between bright dialogue control and broad coverage of topics. And social bots of Alexa Prize, they might look a bit academic to you, which makes a lot of sense, like we are academic team. But in practice, the social bots are far more complex than modern chatbots built with the ordinary tools. And in a way, they're very similar to how Alexa is built, how Google Assistant is built, and so on, because they also use this multi-skill approach to manage the dialogue. But unlike them, the social bots are actively iterating towards the next generation of conversational AI systems. And the reason for that is quite simple, frankly speaking. When you want to build AI assistant, you have to be very, very careful, because if you have consumers who are working with your AI assistant, any kind of mistake might be very costly thing from perspective of legal costs and image damage and so on. At the very same time, you need to have a safe environment where you can interact with your users, make mistakes, and not be punished for that. And one of the ways how Amazon approached that was building this competition, where it is a social bots built by university teams that interact with their users. And while there are lots of ways to block offensive words and other things set back to the users, nonetheless, this is still a fantastic opportunity to innovate faster than the platforms are innovating. And for us, we took a dual-sided approach to tackle a problem of building AI assistants. We participated in these challenges, and then we built a platform. Then we participate in challenges. Once again, we get a lot of feedback, and this feedback loop is quite quick. So we can build lots of great things very quickly and bring them back to the product and then back to the audience. And on our hand side, we decided to use our very own conversational AI orchestrator called DeepPavlov agent as a foundation for our social bot. And for it, we built about 30 skills and like 20 annotators and something like that, powered by NVIDIA GPUs. And then we combined them into one consistent, coherent system. Dream Platform was initially developed during our participation in the challenges. And then we significantly improved it in Alexa Prize 4. And this is the average ratings we had during the competition. The social bot, as I said before, is based on the agent platform, so it has container-based architecture. Its pipeline is highly distributed and can keep up with loads of North American Amazon Alexa users during the competition and much more. During the competition, we had like 7 RPS, but our architecture can scale to 10,000 to 100,000 of RPS based on the calculations of our colleagues who built the agent. Now, let me briefly explain you the architecture. So multiple annotators here are used to extract information from the user's input. We extract named entities, we extract sentiment, emotion, we figure out whether the question or a statement is given by the user and so on. Then a skill selector defines a subset of active skills based on the extracted information. The third moment is that selected skills, they can be template-based, they can be generative, and so on. They generate response candidates. Then we filter out the candidates that are not good enough. They can have words that should not be said or can be offensive based on the sentiment or emotional toxicity annotators. And we also use something in Alexa Price, we use something called conversational validator coming from Amazon team that allowed us to understand whether the response would be on topic, would be engaging for the user, and so on. At last but not least, a response selector picks the remaining hypotheses and decides whether to respond with one of them or combine them together, or maybe come up with a different response. Usually the different response is when we have to change the topic or there is some dummy response and so on. And what is important to say is that all of these components, except skill selector and response selector, can be running and usually are running in parallel. So we can scale up as much of the copies, replicas of containers we need to scale up for the needs of production, and the only 2 points of synchronization are skill selector and response selector. Now, after 2 runs in the Amazon Alexa Price, we've transformed our social bots into an open source multi-skill AI assistant platform. And we call it DeepPavlov Dream because we love to dream, and that's the biggest dream of DeepPavlov Laboratory. And in a way, it is an answer to Amazon Alexa. While there is Rasa, Microsoft AI, and Genie from Stanford, Dream enables development of the multi-skill AI assistants easily. It's an open source platform. We shipped the early version, the first version of it just like half a year ago in the very end of 2021. From the infrastructure perspective, each distribution has a common conversational AI layer, and then its own Docker Compose file listing all of the participating microservices, as well as the agent pipeline configurations that represent the pipeline itself. We also use NVIDIA NeMo for ASR and TTS purposes as a pluggable services, and we first presented that integration at NVIDIA GTC Fall 2020, a couple of years ago. The scripted skills and the system are mostly written in our domain-specific language called DFF, a dialog flow framework. And they enable the social bot or an AI assistant to discuss different societal topics or reach particular conversational user goals in the unified fashion. I'll briefly talk about DFF later. Here's just an example, one of the skills. Now, once the skills have provided the response hypothesis and response annotators added their own weight, response selector uses a relatively straightforward logic to pick up for the next response. Let me change camera a little bit. And as all of the services in our platform are stateless, the dialog state itself is a huge dictionary containing all of the information collected about the user during the session. It's information about the user and the bot and the conversation itself. That utterance can only contain not only text, but also annotations and full response candidates list. Okay, so now that we've got a high-level picture of how DeepPavlov Dream is organized, let's talk about how we actually built knowledge graph components in it and how you can actually leverage it as well. So there are 4 components. Now, one is factoid annotator. It's an annotator that basically figure out whether the user utterance is a factoid question or not. We've built it on top of the data sets we collected during Alexa Price 3 and 4. Then we've built a factoid QA skill. This is a skill that answers to the factoid questions like who founded Microsoft, or who is Elon Musk, or what is the capital of Malaysia. The third thing is entity extraction service. An early version of it is basically a mechanism that allows us to extract entities from the user utterance and then link it to knowledge graph, in this case, Wikidata. And at last but not least, we have a DFF art skill. It's both one of the many scenario-driven skills that we have in the system that helps us to cover different societal topics. And also there's an example of a knowledge graph infused skill that illustrates how we use knowledge graphs for zero-shot entity extraction and production. And you can do that too. So let's quickly look at all the components here. The factoid QA skill, it uses 2 subcomponents of our library, KG-QA and ODQA. And it answers, as I said before, user queries like who founded Microsoft and so on. The factoid QA skill components starts with KG-QA, which finds an answer to a factoid question in Wikidata knowledge graph. The pipeline looks as following. So in the beginning, we receive annotations from entity linking, which helps us to identify this replica, this word Microsoft, right? And link it to Wikidata entity for it. Then we extract all triplets in Wikidata with linked entity like Microsoft instance of software company, Microsoft like Bill Gates, and so on. Then it ranks relations in triplets, like founded by the relation with the highest confidence in this case. And then it returns the object in the triplet with the highest relation confidence as the answer, Bill Gates in this case. ODQA, unlike knowledge-based question answering, works a bit different, quite different, frankly speaking. So it finds an answer to a factoid question in Wikipedia pages in our case. While in general, ODQA can work with any kind of a text. You can go to demo.deepavlov.ai and interact with it. But in this case, we work with Wikipedia pages, not Wikidata, but Wikipedia. So in this case, pipeline works this way. So we extract top-end progress from Wikipedia with a high dot product of TF-ID of vectors of question and paragraph. Then we extract candidate answers from paragraphs with extractive QA model, Triton squad to the toe, and then we return the answer with the highest confidence of extractive QA model. So basically, it allows you to find the answer within the text, which is super cool. But the practical application of both components shows us that only when we use them together, we can achieve good quality levels for the service. Now, the second big component, or the third, if we're going to mention the factoid annotator, is our entity extraction service. Basically, it has an API very similar to the underline.u, and it has a way to extract 42 data types. It uses entity detection service. Then it puts Wikidata into SQLite database, not in RAM. It classifies data by types, and then does perform entity debugation. And it's very small. It's actually running on this computer right now, and it has small memory consumption, and it certainly uses some amount of GPU as well. Let me try to quickly show it to you. So to show it to you, let me try to show you an example. Let me do a new share. I will I'll open one of the applications here, and give me a moment. Yeah, so that one is not running. So yeah, I will open the Postman for the time being. I think this should be good enough for the beginning. So this is Postman. Let me make screen a little bit smaller so it would be easier for you to interact with it. And let me make it a little bit larger. So currently this service is running on my local machine, but later today we will post a link to it. So we send a query like this one. Successful crew demonstration will make Boeing the second private company allowed to ferry NASA crews to the ISS, and will make Starliner a full-fledged competitor to the SpaceX Dragon crew capsule. And here, as you can see, is the output of the service is very similar to the one that Dandelion provides to you. It starts with annotations. It has types. Currently, we support just 4 DBPDA types, but we'll support way more in the coming releases. It provides the ID of object from Wikidata, which is a bit different from Dandelion, which provides all the IDs coming from their own database. We also provide a URI to Wikipedia, which starts with HTTPS compared to Wikidata to Dandelion. We also have abstract, label, categories, images, and so on. There are a few differences. We don't provide LOD for DBPDA for the time being, and we also provide internal data about other candidates. So this is a candidate that we didn't choose, but they can be used for further debugation on your site. For example, here we've got Boeing as a company, but here it's Boeing commercial airplanes. And this is the second option that we picked, that we could pick, but we didn't decide to pick it. There's the NASA, the same story, and so on. Sometimes when we can extract objects that are not resolved through Wikidata, but just general types that we support, one of the 42 types, we put them in unlisted annotation. In this case, it's empty, but in case it wouldn't be empty, we would put some information here. So you could use it as supporting information for you. Okay. So this service will be available later today. It's a very early preview. It's very, very early, and it's quite buggy, to put it this way. So we're anxious to hear your feedback, and we'll be really, really happy to hear what kind of problems are there. And we'll also publish a blog post later today linking to the service, which will outline all of the limitations of the current version. Anyway, so how the service works. Now, basically, it it starts with a fine-grained NER. It identifies 42 types, as I said before. Those tags are then mapped to Wikidata types. And this output is the first thing that you interact with in the service. Then we do entity detection, and we identify entities in the text, and we specify those tags in the document or in the phrase. As the third step, we augment entities with their Wikidata types and links to pages. The service was actually born from Wikiparser, which was created for Alexa Prize for Dream SOCIALBOT that we built during the competition. And it shows us IDs of the objects, the tags that we had before, but IDs come up here, not before. And entity pages also come up here. We also extract actually abstracts and categories and other things from Wikipedia and Wikidata. So we can extract lots of information if needed. And in the end, we send the response back to you. So this is not the end service. The end service, as I said before, provides a response very, very similar to Dandelion with very few differences. And as I said before, we'll publish a blog post later today showing you how you can interact with it. Okay, so and the fourth, coming back to knowledge graph infused components in the DeepPavlov platform, the fourth component is art skill. So the art skill is an example of scenario-driven skills that uses entity extraction to detect and discuss entities. So here we start a conversation with a bot. Actually, we can talk to DeepPavlov Dream SocialBot and dream.deepavlov.ai. And when you have a conversation with the user, with a bot, sorry, and you discuss drawing, it might ask you what kind of pictures of painters you like. And if you say one of the names, it will figure out that object and put it back into the conversation. Here's an example how it does it. So in our DFF skill for art skill, in this case, we do the following. We use entity extraction service here. And we say that in the user phrase, we expect user to say something with a specific type of Wikidata. In this case, it's painter. And then whatever is said by the user is saved to the slot here. That slot is then filled by the system, and then we can use this slot later on in the conversation, like bringing a response made by the bot back to the user. This way, we basically obtain a zero-shot entity extraction service because in this situation, we don't need to tell the system about the slots. We can easily use entity extraction service to automatically identify lots of different types of data. What's important is there are like 42 types, so it's a lot of things you can base your system upon. Now, the whole stack of DeepPavlov conversation AI technologies looks like this. At the bottom, we have models where we have DeepPavlov library, and then we have engines like DeepPavlov agent, which is an orchestrator for multi-skill AI assistants, Dialogflow engine, which is our NEUROSYMBOLIC engine, allowing us and basically you to run skills on top of it. Then we have Dream as a multi-skill assistant platform, Dialogflow framework, which allows you to run single skill chatbots And then we have developer tools like Dialogflow Designer, and later we are going to build, going to ship Dream Builder, which would allow you to build entire multi-skill assistance of Deep Dream and Dialogflow engine. Now, how you can actually leverage all of this to build your own multi-skill AI assistance. So in the beginning, what you need to do is you can just go to github.com/deepmip/dream, clone it to PC or to Mac, and create your branch from main, run a distribution with proxy. This is an important line. So basically, DeepPavlov Dream is a huge thing. It's really big. And because it's so big, you might not want to run it on your local machine. So in this case, you can use our proxy that runs in our data center, and then just run the components you want on your own machine. There is a way to, it's not specified right on this instruction line, but there are more detailed instructions in our repository on GitHub, which specify how you can tell the system which components you want to run locally. Usually this is a skill, sometimes it might be one of the annotators and so on. And once you've done that, you can install DF Designer, which is an alpha version. It's available in the Visual Studio Code Marketplace. And in it, you can go to your skill, like DFF template skill. You can start with it and go to scenario subfolder and then open main.py file where you can design your skill. And then once you design it, you can talk to a distribution. So that's how you can start. Now let's go into the details. Designer itself is available in Visual Studio Code Marketplace. It started as our research project, and we originally introduced at the conference IMNLP in Dominican Republic last November, half a year ago. And while the tool was a research tool in the beginning, we are also working on making it available for the general public. And basically, it's an extension for Visual Studio Code. It uses Draw.io. That's how it looks like for the time being. And it allows you to see your conversational design of your skill, of your DFF skill on Draw.io. And it has a specific recommendation system. So when you, if you specify property of the given node, where the system responds to the user with a speech function or with a Midas dialog act, the system will provide a recommendation of what might be the next step from the user. And this way you can quickly design your conversational skill as long as you understand what Midas and speech functions are. I'm not going to discuss a lot this subject today, but there is a paper that we published at the IMNLP last year. And I believe there should be at least one of the recordings and video recordings that illustrate how you can do that. Anyway, so to build a knowledge graph infused skill, let's look a little bit at the concept. So while DeepPavlov Dream in general is orchestrated by DeepPavlov agent, individual skills are running using DFF, Dialogflow framework. Each Dialogflow skill has something called script. This is a script example of a script, very simple example to think of it. The script has flows. Each flow is a number of nodes, and between each node, you can have one or more transitions. The transitions, they use some sort of condition here, which specifies how you can go to the next node. So for example, if you start talking to the user and we say hi, and the user says hi back to us, then we go to how are you node. Otherwise, we go to hi node once again, condition true. The order in which these conditions are set is important. So the system will always go from the first condition to the second one. So the top node, top condition has top priority. We built about, I don't know, 20 to 40 skills in DFF at different times. They're running in one virtual museum in one New York startup. They've been running during Alexa Prize 4 and so on. And we have multiple different conditions here. They are based on regular expressions, direct string comparison, and they also use a lot of our annotators. Now, flows are different, and you can have multiple nodes in the same conversation. And there is a way to basically move a transition from one flow to another. This is an example. So if we say how are you to the user, we can then transition to node 2 here. But we can also move to the other node. So for example, in the music flow, we can specify transitions. That's all what I know. We can go back to node 4 in the greeting flow, which is an interesting way to go back to the previous flow. So these are very basic ideas. The system is actually very powerful. As I said before, in conditions, you can use all of the annotators that are available in DeepPavlov. And there are also a good number of examples that illustrate how we can use specific keywords like label, forward, label, previous, and so on to move between components, and they are quite straightforward and self-explanatory. Now, the question is how you can use knowledge graph in your skill. As I said before, the art skill is a very good example. You can use components from the art skill, and then you can use the same approach here. So you basically say that you have some custom functions and you specify the data type you want to extract to find in human utterance. Then you can put that extracted object into the slot, and then you can use slot filling to use this object later on in your conversation. So it's very simple and very straightforward. It is probably important to clarify that the entity extraction service we have available in DeepPavlov is a little bit different from the one I just showed to you earlier today. But overall logic is pretty much the same. There might be small difference here and there. The important thing, though, is that entity extraction service that we use in DeepPavlov is designed to support smaller texts that are typical for conversation, while the entity extraction service that I've showed you earlier today and that we will ship later today, early preview of it, will be eventually tuned to support larger texts. Okay, now that I covered how you can use knowledge graphs in your own multi-skill AI systems built on top of DeepPavlov, let me a little bit talk about the futures and what we are going to make available next. So basically, there are 4 things that we want to ship. It's an updated version of entity extraction service that will support custom knowledge graphs. We'll also ship a bot and persona knowledge graph service, which is something that Rami, my colleague, who is actually here today, is working on. The third thing is relation extraction service. It can extract almost 100 relations for English language between entities. And also a custom knowledge graph skill that will utilize this bot and persona knowledge graph service and our relation and entity extraction services as well as example. Let's look a little bit into these components and what we're going to build next. So the entity extraction service VNEXT, as I said before, it will support extraction of custom of extracting entities from the custom knowledge graph. So it will have a new API endpoint for a custom knowledge graph. It will support automatic knowledge graph parsing, and entity linking will link to entities in this custom knowledge graph and provide those things back to you. So imagine a user is talking to you and user wants to talk about products of your company. And obviously those products of your company didn't get into Wikidata, maybe yet, maybe they will not get there because there are usually some high-level bars to whatever is added to Wikidata. And in this case, if you already have knowledge represented in some form of the knowledge graph, we can you can just add your knowledge graph to the system and then do linking back to it. So imagine that you have an object called XT3600, and this is actually a line, I believe, from one of the fictional composer company from Microsoft developer tools. And And the service basically will allow you to do the following. So it will find the substring for the product. It will identify its ID in your knowledge graph. It will also identify tags for the product. And it will also give a link to your Wikidata page, which not going to be a public Wikidata, but your variation of Wikidata or Wikipedia of sort, internal Wikipedia. The second service is bot and persona knowledge graph service. Now, this one is interesting. So basically, when you want to have information about your user in the company, there is a couple of ways you can do it. You can extract it as features, or you can extract it as facts. As a company I worked before, extracting features about users was useful, and a lot of marketing segments are usually built on using those features. But as I said before, my previous experience at a large internet company helped me to realize, and not only me, but my colleagues as well, is that when you have facts about your people, your customers, you can provide much more relevant recommendations. Now, the question is how you can extract and use those facts in the system. Obviously, you can use a key-value storage, and that's one of the ways. But if you want to see connections between those entities, if you want to figure out those connections and use them, like, for example, you have a user who talks to your AI assistant, and, for example, you are a bank, or like Erica from Bank of America, or something like that, and your user says that they are traveling from Washington State to Florida, and at some point they say that they want to send money to their cousin in Florida, then your AI assistant might actually say a recommendation. So if you're flying to your sister, I can help you to find cheaper tickets, airline tickets, for example. And to make this happen, a lot of calculation has to be happening. And you have to connect your sister to ground it to the public knowledge graph like Wikidata, and you have to ground it to a state, Washington State, and the Florida State, and so on. You also have to go to different services like airline booking company and so on. And then you need to make those calculations happen. So for that, we decided that we don't want to use just key value storage. We decided to build a knowledge graph and a custom knowledge graph. And now the thing is, we don't know how the ontology should look like. The thing is that they're usually hard ontologies, like the one in Wikidata. And then for your organization, it's usually not really easy to build a hard ontology. One of old friends of mine who used to work at SQL Server organization at Microsoft like 20 years ago, he told me a very interesting thing, an insight, if you like, how enterprises were using XML property, which was added as a column type to SQL Server 20 years ago. It was interesting. So basically, they had normal tables in SQL Server, like everybody does. And then they had this special column for XML. And for schema, the part of the schema that they fixed on, they just use that schema in the normalized tables. Now, the data that was not normalized yet, that was moving back and forth, they put that into the XML column, and that helped them to have the flexibility. Now, the question of how to build a custom knowledge graph is a big one. After that time, Microsoft established a specific product called Windows Future Storage, WinFS, which was specifically designed to have personal knowledge graph on your local computer. And they built a hard ontology for it. And after, I don't know, 5 or 6 years spent on this product, they decided to ultimately cancel it back in, I don't know, June 2006. And when Microsoft decided to restart this project once again, they realized that they cannot hard-code hard-coded ontology. They cannot put it into the system. They had to make an abstraction, because it turned out that when you put a hard ontology into your product, it's very hard to get people use your hard ontology, because meanings of words would be very different. I recall an example when I worked at Microsoft. I talked to folks from VNEXT team, ex-VNEXT team, and one of the things they told me was like, Daniel, imagine we have an object called message, like system.message, and that was a fully qualified name of the ontological type for message. And they said, like, Daniel, what do you think message is for? And well, at the beginning, I thought like message is like a short message like SMS. And I think, yes, but we also have Outlook team. Back then they call Hotmail. And then we have Exchange, Microsoft Exchange, which provide services for enterprises, mail services. Now you have Outlook, which is an Office Outlook application. And we also have Outlook Express, which is a consumer-friendly variation of a mail client. And then we have services like we have Windows Communication Foundation, which was like the next thing after web services. It utilized SOAP and XML heavily and so on, and they also had a meaningful message. But then they had MSN Messenger, which evolved into Windows Live Messenger and then was superseded by Skype. And then they also had something called Windows Messenger, which in 2004 was rebranded as Microsoft Office Communicator. So as you can see, they had like 20, as I said, they had like 20 teams, different teams. They had a word message, object code message, and they couldn't agree with each other what that message is all about. And it turns out that when you have a hard-coded ontology in the product like Windows or something like that, it's almost impossible to have the hard-coded ontology to be used by everyone. So everyone will have to introduce their own data types, and so maybe that sort of commonality is not important at all. And so instead of that, at Microsoft, they built something called dynamic ontology. And later on, it turns out that Palantir, which was co-founded by Peter Thiel from PayPal, they use the same approach of dynamic ontology, where you have a very simple hard-coded ontology, which is super generic. And the rest of information is saved in the properties of your entities. And that is simple. So you model data as a set of entities, properties, and relationships. And it's interesting to me that both of Microsoft and Palantir build this approach on their own. I worked at Microsoft back in the time when this happened. And Palantir shipped their first videos about how they designed this dynamic ontology, I believe somewhere around 2009 or 2010, way after Microsoft built their technology and present at the Microsoft Professional Developer Conference in 2009 in LA. And what's interesting here is this ontology is very simple. So we have entities, and then you have properties of those entities and relationships between entities. And in our case, we also add actions. And then you have two layers of APIs. The first layer is API endpoints for defining your custom ontology. And that means that every of those objects, entity, property, relationship, or action has some special property called kind. And that kind, it's a text field. That kind, it can be designed by anyone. You can still build your very small ontology into the system, just to give an example of what you can build upon. But that ontology is no longer leaked into the way how you organize your storage of data. And because of that, you can change ontology very easily, and you don't have to change underlying storage. And so this first API layer allows you to define custom types. I can probably show you a very simple example how you can do that. Yeah, so let me show you a very simple example how you can do that. Yeah, it should be somewhere around here. Give me a moment. Lots of different windows on the screen. Okay, where the hell is this window is? This is a rather powerful machine, so it runs lots of applications at the same time. Yeah, so this is an example. This is a startup I worked on it before, long time before, prior to DeepPavlov. And in it, you have different kinds of objects here. For example, this is a document. This is a sticky note. You can also have any kind of object here. Let me show it to you. So can right click and you create a person or organization. For example, we can say that this is an organization and we can say that this is Boeing. I can also have custom data types, like, for example, can custom. When I say custom, I can pick one of the types from the ontology. By the way, this ontology has been expanded by different services here. And you can create a custom data type. So, for example, I can say that there is a data type called spacecraft. Then I can say spacecraft for search. Then I can say custom kinds spacecraft, and I can say spaceship spacecraft, and I can say that this is a kind. I can define it, and then I can create it. And now this is a new spacecraft. So the thing is, when I right click on the object, there is a window here, and this is that the kind is spacecraft. And the thing is that the spacecraft is something I created ad hoc. Now I can go, for example, somewhere here and say that this spacecraft and Boeing are somehow connected to each other. There are a couple of relationships that are basic for the system, like connected to and describes, but I can also define a custom relationship, which is like this, is built by, and the relationship would be is built by, and custom relationships space is built by. Now I define it and I use this built by. And now when I click on this, is built by a new spacecraft. By the way, I can also show example of how Dandelion and our service extract things from it. So this example, so there is a space flight and so on. We can grab, for example, SpaceX Dragon. And we can also treat it as a different data type here, like spacecraft. And now we note that this is no longer just a concept, it's a spacecraft. And here is an example of our service. As you can see, it's still early in development. We can grab the same text here, say X-ray, and we'll find a bit less objects here. We can still find the SpaceX Dragon. And we can actually say that these two are the same. So known as. So this is where you can see the power of the system. So the ontology is dynamic. All the system knows is there are entities, they have properties, and there are relationships between them. But at the very same time, you can also go to something called ontology browser, and feel free to let me know in the comments if you can see the ontology browser. I'm just not sure about that. Rami or Nastya or Maria, folks, if you see, yeah, you do. Okay, great. So this ontology browser allows you to see the objects that are of different types. For example, we can click on spacecraft, and now we have two objects here: SpaceX Dragon and new spacecraft. I didn't treat the third object as a as a spacecraft yet, so we have just two of them. Now, if I go back to the window here and I say treat as, and I go to spacecraft as well, yeah, and we go back. Yeah, this is not running over the not that quickly, but now it's here. So we have both of objects here. Yeah, Protege. Yeah, so Protege is a cool tool for designing ontologies. In this case, this is just a browser, not exactly a browser. For user-defined types, you can actually change things a little bit. So you can change a thumbnail or something like that. Okay, so the thing is, and you can obviously create kinds, and you can create relationships and so on. So this is just an illustration of how one can define your custom ontology. And this is big, or at least I believe that this is big, and so does Microsoft, and so does Palantir. And when you have this dynamic ontology, you have lots of flexibility in interacting, in building the knowledge graph about whatever you want, be it your products, be your services, or something like that. And it's very powerful. Okay, so this is, I believe, the second big thing that we're working on at DeepPavlov. And one of the very specific aspects of it is a temporal view. So if you go to Neo4j or to any other knowledge graph, most of them anyway, you will figure out that they have just nodes and relationships between them. But if you actually want to build a representation, a symbolic representation of the world model, you don't just want to have facts. You want to know when they became facts, when you learned about them. And that's important. For example, you had, imagine you are like a bot, like Cortana from Halo games. And you started talking to your user, like Master Chief. And at some point, like Master Chief said that he knows Sergeant Keys, if I'm not mistaken. No, I think it was Admiral Keys or something like that. And then a couple of weeks later, he says that I'm going to have a meeting with Admiral Keys. And the thing is, if you yeah, in the first case, he would just say that he knows Keys, and the second time he says, Master Chief says to you that he's going to meet Admiral Keys, right? So now in the first time, you just learned that there is somebody called Keys, and he or she is a friend of your user, Master Chief. But after the second conversation, you've learned that actually this Keys is probably an Admiral. And because we didn't discuss it before, maybe it's the same person, so we can disambiguate things. And then you can record this knowledge that this Keys is actually, in fact, Admiral Keys. And that's pretty cool because that's what you learned. But now if you put that in the knowledge graph without temporal aspect, you would lose the fact that before that you didn't know about that, and now you do know about that. And if you know this information, you can do a lot of calculations about your user, do a lot of calculations in your knowledge graph. So this is one of the aspects they're also working on. Here's an example of ways how we use Neo4j about our backend. So what we're building is an API layer, abstraction layer, two layers, as I said before. One of them is for designing your custom ontology and editing it. And the second one is API layer that works on top of Neo4j, allows you to work with those kind of entities. This is just an example of data that you can put in the system. This is very dummy data. We are currently building larger data sets that will represent more information about the user in a human readable form. And here the type is very much dummy data. It's not a real data type. But other things here are like properties and so on that can be stored later on in the system. Okay, now the final component I want to mention a little bit, this is not a complete slide, by the way, strangely. So is a relation instruction server. So I said before, we have a system which has 97 relational types capable of being instructed between entities in your text. And we are going to make it available both to the Dream and as a general public available service. And I cannot add anything more to it for the time being. So for relational servers, that's about it. Now, before I will continue, let me very quickly check. Yeah, so I can actually show you the demo of the system of the entity extraction service that we have right today. Let me do new share once again. Let me at least let me check. It might actually be buggy, but I really hope it's not. Max, this is on you. If you're listening, this is on you. Yeah, so it works. So this is the service. Right now it's available here, 7040.deepavlov.ai. All you need to provide is just text, as I said before, and it will provide you information about the system, about whatever is said by in your text. So as I said before, there are lots of limitations. I will publish a blog post later today describing those limitations to you. We encourage you to use the service and let us know what you think about it and what kind of things we need to fix, in addition or to the limitations that we're planning to fix in the coming days and weeks and months. But this is something you can try out for the time being. This is not production ready. We don't give any service level agreements to it or anything like that. We can get it down at any moment in time. We just want to give you a chance to try it out and let us know what you think about it and what you can do with it. It only works with English language for the time being, and probably it's gonna stay this way for a while. It currently supports only 4 types from DBpedia, agent, organization, company, and person. But we will probably add support for almost 600 classes of DBpedia ontology once we'll figure out how to map them to Wikidata. There's some open source code available in DBpedia, so we'll probably utilize that to give that functionality back to you. So let me go back to the slides. Where are the slides? Yeah. So feel free to talk to Dream SocialBot at dream.deepavlov.ai, and feel free to install our dev designer. Feel free to clone a DeepMeep/Dream, our multi-skill AI assistant, and let us know whether you were able to successfully build your first knowledge graph infused skills with DeepPavlov Dream, and let us know if you've got any issues with building your own multi-skill assistant as well in general using DeepPavlov Dream platform. Now, if you have any kind of questions, I will be really happy to address them. And there are colleagues of mine, Dmitry Evseyev, who is our biggest guy behind our knowledge graph efforts, and Maxim Telemanchuk, who helped to coin the service. There's also Rami, who is building our bot and persona knowledge graph service. So I'll be really happy to address your questions, and I hope my colleagues will be able to step in as well. So yeah, if you have any kind of services, feel free to just write down in the chat. Chat should be available to you. If you also want to ask by voice, I could probably give you a way to do that as well. I think you should have the way to unmute yourself and ask questions by voice. Yeah, thank you very much. The thing is, it's available today, so we can go and use it. It's not like it's just a research talk where you give a talk and then nobody is able to use a code. In this case, you can just go to github.com/deepmeep/dream and start using it today. These slides will be updated and published. There is a copy, earlier copy is already available on zenodo.org, so I will just link to them in the blog post, and I will publish a blog post hopefully by the end of the day today. If you want something from the entity extraction service, let us know. We'll be happy to figure out if you could add this to the service or not, or if you're actually building that. Just didn't talk about this yet. I would also like to stress that this is like the very first time we're showing the demo of the service in the public. So we mentioned it at the Knowledge Graph conference like 3 weeks ago, but we didn't have a chance to showcase it. This time we are showing it to you. We are very, very nervous. We had a crazy last few days testing the service and so on. So it's like doing its very early baby steps. So yeah. Okay. So if you don't have any more questions, I think we can wrap this up. I'm very, very thankful for you to joining us today. And as I said before, I will publish a blog post later today showcasing examples how you can use our anti-extraction service. I will also link to these slides from the Knowledge Graph conference. They are not that different from this one. And you can talk to us at forum.deepavlov.ai. You can talk to dream.deepavlov.ai to the SOCIALBOT itself. And there's a lot of information available in our Medium, where we explain how we build a bot and so on. So I want to say big thanks to all of you for joining us today, and looking forward to see you in our community. I also want to say special thanks to Nastya and Polina, who helped us to organize this community call today. Have a fantastic day ahead of you.